Hello guys, welcome back into this new video. So today we are just going to be looking at the fifth question that was sent in June 2025 Math Mechanics. So for those who have never watched question 1, question 2, question 3, question 4, please endeavor to watch them because they are actually interesting videos. Okay, so without wasting much of your time, let's just get started. The question read, a particle is projected from a point O with speed 52 meters per second at an angle theta to the horizontal, where the tangent of theta is equal to 5 on 12. Find A. The distance from O 1.5 seconds later after the projection. That was 5 marks. B. The maximum height attained above the point of projection. That's 2 marks. C. The time taken to attain the maximum height. 2 marks. D. The horizontal range and total time of flight. That was for 4 marks. So this question had a total of 7, 9, total of 30 marks. Okay, so after reading this question, immediately what comes to your mind is projectile, right? Yes. So in that case, you have to sketch the diagram representing a particle that is being projected from a point. Remember, math mechanics generally students have difficult math mechanics because they don't know how to come out with a diagram. The moment you come out with a good diagram, then everything is okay. Then you have solved 50% of the question already. Yeah, because all your analysis will be on the diagram. Okay, so let us proceed by solving the question. The particle is projected from a point O is between 52 meters per second at an angle theta to the horizontal. So this is actually the particle that is projected. Since it is a projectile motion, so the curve will be parabolic. Yes, parabolic. The initial speed is 52 meters per second. Then angle theta. This is the angle theta here. I think this is just and this is the original point here O. So I think that's all about the diagram. Now here now you have the right angle triangle. It told us that tan theta is equals to 5 on 12. So you mean that if you have this our right angle triangle, this is theta here. So we know that from SOHCAHTOA, the tangent of theta is equal to the opposite over the adjacent. So the opposite is 5 because this is the opposite to this angle. Opposite to this angle here is 5 and adjacent to this angle is 12. So the remaining side will simply be this length here and we're asked to look for this length. And to look for this length, we simply apply Pythagoras theorem. Yes, we simply apply Pythagoras theorem. And to apply Pythagoras theorem, we know that this longest side is usually the hypotenuse. So the hypotenuse, Pythagoras theorem states that the hypotenuse squared is equals to the sum of the side squared and the sum of the two side the sum of the side squared. That means this side squared plus this other side squared. You mean that if you let our hypotenuse should be h, you mean that h squared is equals to 12 squared plus 5 squared. And you have something like 160 something. Yes. And for you to have h now, you are going to just take the square root and you have 13. So feel free to do this. Actually, this was not that necessary, but I just said let me just do it. That's why I did not include the calculation there. But I know you will do it and you can do it. Yes. Okay, so if you had the hypotenuse should be to be 13, it will simply means that for you to have sine theta will simply remember sine theta is equals to opposite over hypotenuse. The opposite is 5 and the hypotenuse is 13, so that's why you have 5 on 13. Then the cos of theta, cos theta is adjacent over hypotenuse, that's 12 on 13. Okay, so that was just an aside, but it's going to help us actually. Yes. So the first question we are asked to look for the distance from O 1.5 seconds later after the projection. That means we're looking for the distance of that particle 1.5 seconds later after the projection. Okay, now you know that when we talk about distance, that means we're talking about, since it is a projectile, that means we're talking about both the vertical and the horizontal coordinate. Yes, because actually the particle should be somewhere on this curve 1.5 seconds later. So at this point here, we are now looking for that distance. You see now? Okay, so now the vertical distance is given by y is equals to ut sine theta minus a half gt squared. That is the vertical distance of a projectile. Y equals ut sine theta minus half gt squared, where u is the initial speed, t is the time, sine theta is the streak ratio. Okay, so you don't see why I was including this stuff here. So that it's simply going to ease our calculation. Okay, minus a half, where g now is the acceleration due to gravity. So if you input all the values there, we're going to have we know u, we know t, we know sine, and we equally know g, 10 meter per second squared. So we're going to have our y to be equal to 52 times 1.5 times 5 on 13 minus a half into 10 times 3 on 2 squared. Remember, 1.5 is the same as 3 on 2. So this is still the time that I've squared. And if you do that, you're going to have your y to be 18.75 meters. So when t equals 1.5 seconds, the particle have traveled 18.75 meter vertically. Now, let us look for the horizontal distance. Now, horizontal distance is simply given as UC cos theta. Thank God we already know cos theta equally from this triangle. So we now see the importance of this triangle. So if you just input everything here, we're going to have 52 times 1.5 times 12 on 13. And at the end of the day, you're going to have 72 meters as your x as the horizontal distance, meaning that when t equals 1.5, the particle travels 72 meter horizontally and 18.75 meter vertically. Now let us now look for the horizontal, that is the resultant distance from O when t equals to 1.5. So if you do that, the horizontal will simply be the square root of the vertical squared plus the horizontal squared. So we're going to have 72 squared plus 18.75 squared. So this I just reversed the values, but it doesn't bother. It doesn't bother since it's addition, it doesn't bother. Okay, so the result of this, we are going to have 74.4 meter northeast, meaning from northeast from O, meaning that 74, that means the particle will be 74. Okay, first of all, when we talk of northeast, that means you're going to the north, then to the east. That means from somewhere here like this, you are going to measure 74.2 meter from O. So that's how it is. Get it right. That's why I said north is not only north, because if you say north, that means it will be something vertical, and if you say east, it will be something horizontal. But I said north is, that means when you go up somewhere here like this, you measure 74.4, 74, yeah, from O. 74.4 meters northeast from O. That's from the origin. Okay, so hope this first part was okay, and hope everybody understood what the question was all about. So question 2 now, we are asked to look for the maximum height attained above the point of projection. Now for us to get the maximum height, we simply need to apply the formula for maximum height. Yes, we know that y max is equals to u squared sine squared theta divided by 2g. We already know everything here. What we simply have to do is just input the values and point. So u, initial speed, is at 52 squared sine squared theta. Sine theta was given to be 513. I mean, it was found to be 513 because we are actually the one who calculated it. 513 other squared then and divided by 2g, where g here is 10, simply 10. Yes. Okay. So if you do that, you are going to have the maximum height to be 20 meters as the maximum height attained by the particle, 20 meters. Okay, you realize that actually the maximum height cannot be below this vertical distance here. This one. The maximum cannot be below this. It can never. Simply because no, actually it makes sense. It makes sense because this is the distance traveled by this is the distance traveled by the particle when t equals to 1.5 seconds. That means it travels 18.75 meters when t equals 1.5 seconds. Now the maximum height now was found to be 20 meters. Okay, that is above the other one. It's okay. Now C, that was all for the B part. C part we are asked to look for the time taken to attain the maximum height. Okay, so the time taken to attain the maximum height, simply we are simply going to apply the formula. Okay, we know that y is equals to ut sine theta. Sorry, okay. We know that this is actually the vertical distance. You know that if y is equals to ut sine theta, right, minus a half gt squared. This is first of all method one to solve this approach. I mean to get the answer. If y is equals to ut sine theta minus half gt squared, this is actually the horizontal distance. Okay. Now you mean that if you multiply all through by 2, we are going to have 2y to be equals to 2ut sine theta minus gt squared. Hope it's okay if you multiply this equation by 2 here. Now what you do next is that you bring this guy here, that is negative gt squared on the left hand side is going to be positive gt squared, and minus 2u t sine theta will be minus 2, and 2u t sine theta will be minus 2u t sine theta. Then now this guy remains here with plus 2y is equals to 0. So we are going to have, if we simplify now this, we are going to have gt squared minus 2ut sine theta plus 2y max is equals to 0. Okay, the reason I'm putting y max here is because we are looking for the time when y is maximum. When y is maximum, we are looking for that time. And we saw that the maximum height was simply 20. From the previous calculation, we saw that the maximum height was 20. So it will mean that if you replace g by 10, we're going to have 10t squared minus 2 into 52. That's the initial velocity. Then now sin theta 513 times t is equal plus 2 times 20 is equal to 0. So if you simplify this, we're going to have 10t squared minus 40t plus 40 equals 0. If it's divided by 10, we're going to have t squared minus 4t plus 4 equals 0. And This is different. This is square of a binomial. We're going to have t minus 2, t minus 2, and we're going to have t to be equal to 2 seconds. So the time taken to attain the maximum height is 2 seconds. Okay, now the d part. But let us come back to this question, please. Let us analyze, because mathematics mechanics is just simply the analytic of questions. Now, remember they told you that you should look for the time taken by the particle to attain the maximum height. And we also knew that when t was 1.5 seconds, the vertical displacement of the particle was found to be 18.75. Now, 2 seconds later, or no, let me just say 0.5 seconds later, the particle goes immediately to 20. So actually, it makes sense. It makes sense actually. It simply means that the maximum height of the particle is 20, and it took 2 seconds to the particle to attain the maximum height. That's the meaning of this answer. T equals 2 seconds. It simply means that it took 2 seconds for the particle to attain the maximum height. Then it took 1.5 seconds to the particle to go to the distance, to go to 18.75. Yes, 18.75. So actually the equation makes sense. I mean the answer, yes, our answer makes sense. Now the last part of the equation, we have to look for the horizontal range and the total time of flight. Okay, now so to get the horizontal range, we know that the horizontal range of the particle is given by u squared sine 2 theta divided by g. So if you input the values, are going to have, okay, before then, sine 2 theta is the same as 2 sine theta cos theta, right? So we're going to have our r to be equals to u squared times 2 sine theta cos theta divided by g, and we're going to have 2 times 52, that's 52 squared, 5 on 13, 12 on 13 divided by 10, and we're going to have our range to be 192 meters. Now the range is simply the distance from wait, let me indicate. Okay, the range is simply the distance from this point to this point. Yeah, the distance from this point here to this point, that was 192 meters. So it's actually making sense still, because 192, that distance from here to here, is greater than the distance that is greater than I think we had something like 72. Yes, it's greater than 72. The range is the total displacement of the total horizontal displacement of the particle. Now, the total time of flight now, let's have the total time of flight. So the total time of flight is equal to 2u sin theta divided by g. And we're going to have here the time of flight to be equal to 2 times 52 times 5 on 13 divided by 10. And if you do that, we're going to have 4 seconds. So actually it simply means that the particle took 4 seconds to travel, to go through this part. To go through this part here, let me show you. Okay, yeah, that means the particle took 4 seconds to go to this part from here to here. Okay, so guys, thank you very much for watching, and hope the video was interesting. Now let me explain another or what I understood from this, that everybody should equally understand. It means that the particle took 1.5 seconds to attain a certain height, that was 18.75. Then 2 seconds to attain the maximum height. That means at maximum height, that means when t equals 2 seconds, the particle was already at its maximum height. That means at this point here. Then now the particle took 2 seconds again now to attain this ground. So that was all about the question, and hope the question was interesting. See you in the next tutorial for the next video. Ciao.